Since I've been doing so much testing lately, I'm gonna test something I've been wanting to do for a while. And that is the theory that you can actually, I don't wanna say dramatically, but you can improve the temperatures of an AIO or any water cooling loop, whether it's open or closed loop, by spacing out the fans away from the rad. Because we've talked about the fact that the hub size of the fan is just dead space that's completely blocked off, no airflow, because when they're seated right up against it, it doesn't have enough air cushion between them. So I've already run some tests, but we need to make the spacer, and we're gonna do some airflow visualization and such, and then I'm gonna run it with the spacer and see if things have improved or not. And hopefully they do. Otherwise this all would have been for nothing, other than to say, doesn't matter. Which is still a valid result.
For those looking for a high-end custom gaming experience, look no further than Falcon Northwest. Falcon Northwest has been building PCs made for gamers for over 30 years with a focus on a true high-end gaming experience. Custom cases available only through Falcon Northwest feature state-of-the-art testing and design to ensure that every component is performing at their best through thermal imaging and rigorous lab testing designed and overseen by the Falcon Northwest founder himself. With a complete lineup of systems ranging from small to large, every Falcon Northwest system includes a 3-year warranty policy and a year of 2-way overnight shipping coverage, providing the ultimate peace of mind. To see all that Falcon Northwest has to offer, follow the sponsored link in the description below.
I have this taped down so tight right now because it kept trying to fall over on me. But anyway, so this is just a Montech AIO, and I think this is a Hyperflow Silent 360, whatever. It doesn't matter what it is that you're using. But what I'm talking about here is to try and get a little spacing, more spacing between the fan and the surface area of the radiator, the fins. It's already recessed about 3 millimeters because you've got the little overhang, but that's not enough. If you've ever taken fans off your AIO that you've been running for a while, you can see that what I mean by the dust pattern, right? So you have a clean spot under every fan that's exactly the shape of the fan hub. So for instance, we have our fan, right? Now the fan obviously needs something to spin on. It spins on the bearing, which is built into the hub. Now the hub has to be supported by these arms. Now all of these things are blocked airflow, even in an open airflow pattern like that. But now, if we take that and smush it against something, no air can flow right there because there's no blades. Now, if we space that out a little more, we actually get the air having a little bit of more movement, I guess you could call it, where it's gonna fill in that dead space because it'll go from being low pressure to pressurized, which means air will flow from high pressure to low pressure. So what we need to do is to get the fans farther away from the radiator, which could actually, in theory, mean we can get at least the same cooling at lower speeds for the fans. That's my theory, because we're increasing the active cooling area of the radiator. So if we take our rad and we were to just calculate the area, in fact, we can calculate the area right now using this fan. Let's get the old mathematics. So we know in a 120 millimeter fan, we have a 120 millimeter diameter circle, and then easy math equations to figure out the radius of that. But if we want to know what percentage this hub alone, and we could even calculate the percentage of blocked airflow by using these arms, but companies have been doing better at trying to smooth that out. You can't really tell on this one, but those arms have a swoop to them to help push air through rather than have it be a flat surface area. But if we know that this hub is 47 millimeters, where 120 millimeter circles, approximately 11,310 square millimeters, or 113.1 square centimeters. And then our hub at 47 millimeters is approximately 1,736 square millimeters, or 17.36 square centimeters, giving us about 15.34% of blocked airflow. This is 15.34% the area, or the size, if you will, of the 120, or percentage of the 120. So that's a big block right there. But knowing the way that the airflow flows, if we split that and push that out farther, we should get a more even airflow through the radiator by getting more air through the blocked off hub area by moving it away. That would mean 15% theoretical better cooling. The reason why I say theoretical is because there's a lot more complication to this type of formula to sort of figure it out. But just looking at the dust patterns show that the area under the hub is clean. There's no dust that really ever makes its way there. So that tells you that's effectively an ineffective area when it comes, well, inefficient area, I should say. The reason why I say we're not going to gain 15% cooling is because there's still some passive cooling aspects to the air moving through the fins, even though there's no real active airflow over that. That's the reason why you can turn off the fans on your AIO, but leave the pump running, and your system is not going to overheat under like idle usage. Under load, totally different story. You'll saturate the loop and eventually it'll just run away because thermal runaway. But I think we're going to see at least 10% improved airflow. Okay, so let's visualize this now. If I put my hand right here, like I can feel in the very center, there's dead spots underneath the fans. I can absolutely feel that all the air is basically coming out the perimeter of the radiator, and then a little bit in the middle, like right here, because that's where the fans, right? There's a circle there, circle there, circle there. But I'm telling you, my finger right now, this is not scientific, feels zero airflow right there. But as I get to the outsides, like around the perimeter, now that's where all the airflow is. And I'm wondering if this is going to demonstrate that. You can see it. You can see it vortexing right there where there's low pressure. So look at that. If I get all kinds of smoke in there, look at that ball of low pressure right there.
That's funny.
See it spinning? Look at that vortexy. Woo. It's like when you blow a smoke ring, but it's just staying right there. So obvious dead zone. Look at that. Look at the smoke. Do you see how it's clearly low pressure right there? But that's crazy to see the smoke ball. Same thing down here. Look at that. That is so crazy to see. I wish I had enough now so you could see all three balls. There we go. There you go. Look at that. It's really faint. A little spinning, a little spinning. It reminds me when you put like a ping pong ball on like a shop vac that's blowing air and it's just kind of sitting in spot. It's doing that because the faster air around it is creating a pressure pushing it back. So if my theory is correct, by spacing this away even a little bit, we should see that area right there probably still have a little bit of lower pressure, but it shouldn't be vortexing as a perfect sphere of smoke that gets caught right there. So we just need to wait for the print to get done. We basically did a single bezel, or shroud, I should say. Not even a shroud. It's a spacer, but it's a 10 millimeter spacer. We could have gone with more, but I want to make it so that if you do decide to utilize something like this, like we got the template just off Thingiverse, it's nothing crazy. That way it would still fit in most cases and such. But I'm thinking, like, I don't know why brands haven't thought of this. Like, you can't actually very easily find fan spacers. And if you can, you find them where they're divided in the middle. And I wanted to bring them up together because I want the conical effect of the fan air, remember the air comes off a fan in a cone shape because of centrifugal force, it's being pushed outward. If you have a divider in the middle right there, I feel like that could affect our airflow in a negative way, but I want to see what happens if we have the air just kind of smashing into each other because I assume we might get some bounce back into that dead zone area. So it's just going to create a single chamber instead of 3 individual chambers through the radiator. Now this is something we might have to do a follow-up later where we do 3 individual spacers that not just space out the fan, but also maybe go all the way down into the radiator to create 3 individual higher pressure pockets of air. So that would be like the next progression of this test. But the print should be done in about 10 minutes or so. And then we'll get it on here and we'll do the smoke test and then I'll run the testing on it and we'll see if we picked up any performance at all. Fortunately, the room is really consistent temp. Right now it's 22.3 in here. It was like 22.6 when we did the last test. I did 76% fan speed and then 100% fan speed because I need to see if we gain performance at lower fan RPM by utilizing the spacer, because that would be the real benefit of it, honestly, is that would then mean at 100% we should theoretically see better performance as well. But with what the case testing and the air cooler testing has taught me recently is 100% isn't always better. So it'll be interesting to see how this one kind of scales. So this is the spacer that was made. It's not a perfect fit. Like we just grabbed one off the internet, but if you look and see, there's not really any overhang when I line up the screws and such, but I'm worried about there being any seal gap here, right? So I might have to put a little gaffer's tape or something on there just to seal it off. But that's something that can be tweaked. The concept here will still remain the same. But here it is, just a 10 millimeter spacer. That's why I mean there's no divider in between them right here. So unless the divider was to go down into the radiator and block off that airflow as well, I think it's better to just leave it open like this. So let's go ahead and get this guy installed. So using the unscientific wet finger method applies to more than just this instance. But anyway, I can feel airflow in the center now. Like before, there was nothing there, and you saw the dead zone. Like it was visually, but I can feel it now. Like right there. The question is, still there a little bit. Okay, maybe that's just going to be potentially
more spacing, maybe?
No, we have a pretty good space now. We have about 13 millimeters of spacing now. That's probably just going to be the sheer fact that the blades don't go to the center of the axis that it's spinning on, right? But I don't know if it's just my imagination, but it seems a little bit less violent or obvious. Probably not. I don't know, it still looks like it's flowing through smoother and straighter to me though. Okay, well, the numbers won't lie. Unless a person writes them in wrong. All right, so we've got a few 10,000 lines of data now that we're gonna take a look at to see whether or not all this effort mattered. Let's go ahead and start with a line graph. So the blue line here is CPU package with no spacer, fans at 100%. You can see when I overlay the same CPU package temp with the 10 millimeter spacers with the fans at 100%, they just follow the same line. I mean, of course, their peaks and valleys are changed, but the trend line is under 70C. So it's actually performing pretty well in both instances with absolutely really no change whatsoever. So if we take a look at 76% fan profile for the same package temperature, you can see the trend line is right at the 70C, whereas on the 100% fan speed, it's in between the 65 and 70C. So really hard to notice any sort of a change whatsoever between even 76% and 100% fan speed with or without the spacer. So this is already not looking good for the theory of spacing it out will actually make a difference by allowing the percentage of the hub that's covering the radiator with direct airflow, allowing it to flow through there. So if we take a look at the E-core and P-core averages, the chart is just a mess, right? Because we have P-core averages, we have E-core averages, we have spacer and we have no spacer, and we have 100% and 76%. So the reason why I just kind of overlaid it all sort of on top of each other is so you can see if you can't clearly define any sort of improvement, it's really difficult to validate saying this was a worthwhile test. Because remember, even though we do have noise or temperature normalization happening here, and by the normalization, I mean, it's like 0.4 C at the most, because we need to make sure everything's at the exact same 21 C that's in this room right now. There's no clearly defined benefit whatsoever to doing this. Now, if we take a look at the actual bar chart, the best case scenario to the worst case scenario is a difference of 1.2 C. So yeah, and it's funny, so you can see right here, the coldest scenario here is the spacer at 100% fan speed. No surprise there, right? We spaced out a little bit, and we have added more airflow. But 68.9 degrees with the spacer at 100% versus the no spacer at 69.2. So it's a difference of 0.3 C with spacer and no spacer for package temp. The core temps are exactly the same with or without, by the way. So I like to look at package temp too, because it gives us a, you know, it's the full heat load. The cores are only generating so much heat, but you have the cores, and then you have the I/O die, which can create quite a bit of heat inside the package as well. If we take a look at the spacer versus no spacer with 76%, 69.6 degrees versus 70.1 degrees. So that one's about a half a degree difference. But if you look at our core temps, they are pretty much exactly 1 degree difference between spacer and no spacer. So 64.4 on the P-core average versus 63.4 on the E-core average. It's kind of funny. The overall with the 76% fan speed with the spacer, our P-core and all-core averages were slightly better, right, with the spacer, but the package didn't really benefit at all. In fact, the package is slightly warmer than the no spacer.
which again, the difference here of 0.5 C is very much in the margin of run variance. So basically this is inconclusive, which basically can be also defined as not worth it, okay? Now I'm gonna do this test again. I'll probably follow up with just a short, to be honest. We're printing a 20 millimeter spacer right now because we're trying to figure out if there is a point where having more spacing matters. But there's one other factor here we didn't really talk about that I think is going to matter here, is although there may not be direct airflow over the 15 point whatever percent of the radiators or the fan's 120 millimeter area is not like switched off from the cooling capability of the radiator. Let me explain. You have a 120 millimeter circle and we have a 15% of that blocked by the hub. But that area that the hub is blocking, it's not like that's disconnected from the rest of the radiator. The heat fins are connected to all the rows. So heat is still being transferred away from there. It's probably just being cooled from a different part of the rad. It's just that heat is going to move away from that area and then it's just being picked up somewhere else. So that's why this was an interesting test to see whether or not this matters. It would matter if that was a section of the radiator that's not connected to the other parts of the radiator that are getting active airflow. So as you start to consider these other factors, it starts to make the benefit of going through all this effort less and less and less. And I have no doubt Asatek and EK and I don't know, Bits Power and all these other companies that make radiators and make fans and make fittings and water cooling stuff, I've no doubt this has been checked and been tested and has probably come to the same conclusion, that the encroachment that a thicker thing takes up by adding a spacer would be totally offset by just adding a 15 millimeter thicker radiator. So we've talked, that's a whole other factor we haven't talked about here. Does adding 10 millimeter spacer to your fans outweigh adding 10 millimeters or 15 millimeters of thickness addition to your radiator? That would be way more beneficial because you're actually getting now more rows, you're getting more cooling fins and more cooling capability and capacity. So no, this was not worth it. Fortunately, it was only a couple bucks worth of material we used, but I'm still gonna try it with the 20 mil spacer. I'm just curious now if there becomes a point where it becomes more beneficial. But I don't think so, because again, those rows and those fins are being connected across the entire radiator, which means that heat is still being taken somewhere and taken away. I would, if it were true that 15% of the circle that's being blocked by the hub is able to make up for 15% of the cooling capability, then we would see 15% improvement in temperatures. But that's not the case because, again, there's so many factors involved here. But I woke up today and I went, I wonder, and then it leads to videos like this, and now we know. All right, guys, thanks for watching. If you have another idea for something we should do and test, I like doing these types of nerdy deep dives or shallow dives, whatever you want to call them. So just send up in the comments down below what you think we should test. If you've always wondered if something matters, maybe we'll come up with a test for it and see what we can find out. All right, guys, thanks for watching. As always, we'll see you in the next one.